Alright, so what we're doing here today is we're machining our pedals for our pedal assembly for the Bobcat Racing Formula SAE team. Currently we're loading our aluminum stock up into the 5-axis and 3-axis machine here. We're currently on our second operation. We're doing facing and pocketing milling operations. We'll be using 1/2 inch and 3/8 inch flat end mills for these operations. So as we take you through this, we'll kind of get a look at what those operations look like and what's going to happen with these pedal assemblies once we're done. All right, so what we're going to do here next is we're going to go ahead and probe the material, the stock for the pedal assembly. We got to get this probe here to probe on the front left corner of the stock, which is what we set up in our program Mastercam. So as I take you through this, we have to go through the offset options here, and then we choose the work offset. Then we can see that we're in G54, so that's the axis that we're on, I suppose. We'll go to F3 for probing actions. We need to do our outside corner because we're going to select that bottom left corner on the stock right there. So we'll select enter. Next, we're going to come down. This gives us our options of corners. Our front left is number 1, so we'll continue to leave that number 1. We'll do half the length of the stock, which is 4.5 inches. And then we'll do half the width of the stock, which is 2 inches. And the depth is -3. So that's something we can use to set the parameters for the stock. Before we can do this though, we have to set up the probe on the part correctly. So we'll go ahead and jog the part over. All right, so with our probe in the correct position for the stock that we set it up to, we'll come back to the offset and enter those parameters that I just set a little while ago. All right, so now we can just click cycle start. And this will probe the part in the middle of the part, and this will get the dimensions for the entire stock.
And so
perfect. So now with the edges outside of the part of the stock is dimensioned and probed. Next we'll do the top surface so the machine knows exactly where the top surface of the stock is at. So we'll come back and do the same thing, come back and jog the machine over. So where we put the probe right down in the center of the part. We'll come back to offsets, work offset, probe actions, and then we can come right over to single surface, which will get the height of our part right here. Click enter on that guy. Next we got to come down to the Z-axis because that's the probe, the height that we want to measure. We want to measure in the Z-axis. So we'll do -0.5, enter that, and we can cycle start, and we'll probe the top of the stock. All right, our stock is completely probed now. What we can do now is change our tool. We'll go over to our first tool of the program.
What is it?
And then what we'll do next is go over into the program and load up our new file for the second operation of this design. So we can come over to list program, go over to USB. We'll come down and select the program that we are going to utilize here, which is Operation 2. Or actually, that's for the brake pedal. We're doing the gas pedal on this side right here. Operation 2 right there. We can select the program, copy it, over to the machine right here. So we can just copy that, press yes, and now we can go back up to the machine And the program is loaded up to the 5-axis CNC mill.
Bro, get in our area, dude.
See, now it shows up. It's in the actual program, or in the actual 5-axis machine. You can see this is our file here. We can click enter on this file, and then now we go to memory. We have our file here, and this is loaded up, ready to run. So what we can do now is we're going to lower the speed just to make sure everything's operating properly, and we're going to go ahead and cycle start the machine. So we're going to put 5% to slow it down just to make sure everything's operating the way it should be, and we can go ahead and start this operation. We're going to go ahead and cut the coolant on as well, just to make sure that we're keeping the part nice and cool.
Which to be figure out how I agree with this. Might be service tired. Hope it's got the books of the other material.
So the tool's going to enter the part nice and slow.
Would you hope like
Victor,
now whenever
Victor, is this on the gas pedal? Is this where the tool's supposed to enter the part?
That. Yeah, so first it's going to do the...
That's right, it does this.
Do the pockets first, and then after that it's going to contour.
Okay, yeah.
They fit in for those 1/8.
All right.
And they...
All right, so now our second operation is done. We can go ahead and open the doors up and look at this. So you can see our first passes have been done. These were pockets here and facing operations. So what we'll do next is we'll go ahead and unload this tool from the machine using this guy right here. All right, so we'll go ahead and pull the part out of the chucks now, out of the vise.
picture from the top of the tape, the brain of the screen.
And there you go, we can get a good look at the first passes. These are two of the holes that we'll be creating fixtures for on the pedal assembly, which is why we cut them first. Nice clean cuts all the way through. Good surface finish. We're looking good to move on to the next steps. All right, so we kind of did our test passes on this plastic material here, just to make sure that our tool paths were correct. We did end up finding some issues with our code, which have since been fixed, as you can tell. But first operation here, second operation here, this is the origin that we located. And then our next operation will be on this side, which will cut out the contour of the actual gas pedal. So we'll go into that process next. All right, so all the parts of machining right now, we're gonna go ahead and cut out this 1" by 1" carbon steel tubing. It is a square tubing. We're gonna use it to mount the pedal assembly to the chassis. So we're gonna go ahead and cut out 19 3/4 inch sections of this tubing and drill some holes so we can create some mounting points for the pedal assembly. So here, create a marking. I'm gonna go ahead and mark that out. I've already measured this up preemptively. And then the other marking should be, I can't find it. Where is it? Yeah. Bye. Right there. All right, so we're going to utilize these two end pieces of this like the square tubing to go ahead and create mounting points.
Hi, my name is Alan Alvarez. We're at the Ingram Makerspace here. We're using our bandsaw, our jet bandsaw, and we're here to cut our steel tubing for our base plate.
I'm Victor. I'm kind of in charge of the toolpaths for the mastercam file that we're working on. We're just trying to get this to measure out much like that gas pedal that you saw earlier. Trying to make sure everything is good measurement wise, because we are probing from different corners. So that's what this is here. So right now this should go, oh, that's the wrong one. We'll wait for it to finish. It's supposed to be 4.5 on the X direction instead of the Y direction. So it just said at the integration thing, that's fine. So it changes to 4.5, and there that should be 2. I'll run that again. I'll stop that there actually. Reset. Coordinate source. So we've got a handle job to do with back up this way. There are times. A lot of this is just trying to get it even, make sure everything's right. So it's a lot of small little increments that we got to measure out here. Let's up the right. We'll come back over here just to double check. All right, that looks good. So now we go back to offset, and we'll run the program again. It's going to be going off of that top left corner there. There we go. So it's going to go 4.5 in that X direction there. Stop. And then tap off the tool, or the tool onto the material, just to make sure it knows where it's at for when we start machining. And it's gonna go 2 inches in there. Do the same, make sure it knows where the part is. Now we should be good to start. All right, so we got our code in here already. We go to our programs here. It's on our USB drive. That is of that one over here. So we will take this out because his is in memory. There we go. Gas brand all on gas pedal. Oh, let me see. There you go. Get the USB drive real quick. Can you give me the USB drive? Actually, anything? Thank you, sir. Beautiful. Right. All right. So here's our USB drive. This is what we're gonna program off. So we're gonna do operation 3. So we select that program, and it should be ready to run. I'll just hit cycle start here in a second. So we have invalid code. So should be an easy fix. We just have to go back and delete some of the code that was giving us the error. So we're gonna go back over here and mess with the code a little bit just to get it right. code is fucked. So.
Yours?
Yeah.
Where is it?
It's just for the machine that we're using. So I have to.
Absolute.
No, it's the.
Oh, so you found what's wrong with it?
No, I found what's wrong with my code. Oh. I have to delete the parentheses and whatnot off of my.
That's it. Forget solving.
Yeah, I haven't solved the actual issue that we have. But I'm about to see if I have the same issue, so we'll see. If you look over here, the reason it wasn't running is because of the little notes there that it has. Basically all it's saying is that what tools we're using, and it's just checking the code to see what's going on and the name of the file. We just have to get rid of that real quick, and it should run perfectly fine when we run it over there. Just get rid of that. I'm gonna scroll down to see if we have anything else that we need to get rid of. It'll mostly come up when there are any tool changes, like right there. It's changing over to a flat end mill. Yeah. So we'll just get rid of that as well. All right. Scroll through the code. Doesn't look like there's anything else. It's just going to be running that flat end mill for the entire time. Oh, there it is. There's another right there. It's changing over to that 0.5. Get rid of that end mill as well. So if I wouldn't have taken these out, what would have happened is it would have stopped the machine and it would have thrown an error code.